Hi and welcome to this session on projectile motion. So what's the question? Well, it is evaluate the flight path of a shot put and it's worth 8 marks. So let's go through everything you need to know on projectile motion. So what is projectile motion? Well, this is the movement of an object or the human body through the air. All right, this could be a ball as it's being kicked, hit, thrown, the ball becomes the projectile, or for example, if it was a long jump, the human body would act as the projectile. Okay, now these things that you need to know. What is horizontal displacement? First of all, that is the shortest distance from the start point to the end point in a line parallel to the ground. Well, there are 3 factors you need to know that affect horizontal displacement. That is the angle of release, the speed of release, and the height of release. What are they? Well, the angle of release then, that's the optimal angle and is dependent on the release height and landing height. And I'm going to go through some examples of that with you shortly. Then we've got the speed of release. This is the greater the release velocity, so the greater something is released, the greater the horizontal displacement travelled. So for example, the faster you release discus, okay, the greater it should travel in terms of in line with the ground in a straight line. Then we've got the height of release. Now, a greater release height should lead to a greater horizontal displacement. If you're a smaller athlete now, you're a bit screwed compared to a taller athlete. So you've got to be able to manipulate the speed and the angle of release in order to reach the same horizontal displacement as a taller athlete. So let's have a look in a little bit more detail then. So here we go, I've got an example. This is a basketball throw. So we're looking at what is the optimum angle of release then. What is the optimum angle to throw the object as far as possible? If you ignored wind resistance, gravity, then the optimal angle is always going to be 45 degrees when the release height and the landing height are equal. So let's have a look then at shooting in basketball. What would be the optimum release angle here? Now, the release height is here and the landing height is all the way up here, so it's higher. If you think this basketball needs to travel up here in order to come back down and land in the net, well, we need to look at what the angle of release would need to be. And actually, this angle here is the angle of release, this what? Okay, now when the release height is lower than the landing height, the optimal angle has to be more than 45 degrees. Okay, so this has to be higher in order for it to get higher to drop in. Okay, let's have a look at another one then. So here we've got a long jumper. Now what's really important here is the release height here is the same height as the landing height, so they are exactly the same. Okay, now the optimum release angle here is 45 degrees, but it's really important that is ignoring gravity and wind resistance. Okay, so the optimum angle here would be 45 degrees. Brilliant. Let's have a look at another one where it might be slightly different. So here we've got a shot put throw. Now if you think about it, the shot put is being thrown from here. Okay, so the release height is a lot higher than the landing height down here. So if we were to throw this shot put, it would go up high and then come down to land down here. Now we wouldn't need to send this really high, so it wouldn't need a high angle of release because it'll just come straight back down. 45, yeah, it'd be nice. However, when it's at this height and coming down, our release angle actually wants to be less than 45 degrees. The actual optimum is between 26 and 38 degrees, okay? That's the optimum angle. So if we've got a smaller release angle, we can generate more speed. So the angle is dependent on the size, the strength, and the technique of the athlete. So it's all well and good saying it needs to be less than 45 degrees, but it depends on the height of the athlete, how strong they are, and the technique. So let's have a little bit more then. So we've done angle of release, so we've done this one, and we've looked at 3 different examples. So let's look at speed of release then. So we've already said that the greater the release velocity, the greater the horizontal displacement. So in the shot put, the speed of the shift, that shuffle across the circle, or a rotation, okay, across the circle, that ensures that the shot put leaves the hand at maximum velocity. We have to do it at maximum velocity in order to get maximum horizontal displacement for that athlete. So let's look at height of release then. So we've already said about a greater release height should lead to a greater horizontal displacement, and we looked at how a smaller athlete isn't obviously going to have a greater release height, so they need to be able to manipulate the speed and the angular release in order to match that of a taller person. So let's have a look then at factors which can affect the different flight paths. Now we've got 2 things that are really important. I'm just going to write them at the top. So weight, okay, and air resistance are 2 forces that affect the projectile, so the body, human body, or the object, okay, in the air. Now these 2 factors are crucial in deciding whether the flight path is a true parabola or whether it's a distorted parabola. Now, what on earth is a parabola? A parabola, okay, here, is a curve with a matching left and right hand side. So if I drew a line down the middle, the left hand side is symmetrical at the highest point, okay, to the right hand side. Now when I talked about weight, I mean gravity. So it's all dependent on how much that object or that body weighs to how that is affected. Now, going back to the parabolas, projectiles with a big weight force, okay, follow something called a parabolic flight path. That one is equal each side. If it's not very heavy at all, so it's a light one, then it follows a non-parabolic flight path because air resistance actually becomes the greater force. So let's have a look at these 2 examples that I've drawn down here. So if we look on the left hand side, we're looking at the parabolic flight path of a shot put throw. And I've put in the arrows for air resistance and weight acting upon that shot put at the start, the middle and the end of the flight. Because a shot put is very heavy, there is a large mass, okay, so the weight is the longest arrow out of the 2 at every single point. Now the longer the flight path, the longer air resistance can affect that shot put, and it will also have a greater influence. Now as you can see here, the weight is greater than the air resistance at every point in that flight path. If we've got a projectile with a lighter mass, so looking back at the shuttlecock then, air resistance becomes the largest force, which means it starts to follow a non-parabolic flight path. And it becomes a distorted parabola. Now, if you can see here, if we compare the 2, the weight force is actually the smallest force acting upon the shuttlecock, whereas on the shot put, it is the greater force out of the 2. And as you can see, air resistance is greater at all points. One thing to note though, is the air resistance actually gets smaller from the start to the middle and then to the end. So it has least effect at the end. So at the surge, to the point where the shuttle is about to start off, alright, it starts with a high velocity, and that's provided from the power by the force of the racket. As the shuttle is then flying through the air, it starts to slow down. That air resistance is taking that effect, okay? However, when it gets to the top, air resistance effect is actually reducing, and the weight force is now starting to become the greater of the two, which is why it starts to come back down. Let's look then at vector components of a parabolic flight. We know that a shot put follows a parabolic flight path, and it's released at an angle in comparison to its horizontal. A vector, okay, is drawn as an arrow. It has a magnitude, which is its size, and it has a direction. Now this can either be horizontal or vertical. Now if we've got a bigger arrow, it means there's more magnitude, and a smaller arrow means there's less magnitude. Now if we think about what on earth these horizontal and vertical components are, well, a horizontal component relates to the horizontal motion of an object. The vertical component relates to the upward motion of an object. Makes sense really, doesn't it? If we add both of the vectors together, we get this arrow here called a resultant vector. And you need to be able to do this for a shot put. And all you do is add them together. Now, this is one thing really important to note. Air resistance is pretty much negligible against a shot put, so the horizontal component stays the same throughout its flight. So let's have a look then. At the start, there's a large positive, because it's going up, vertical component. The shot put is released and travels upwards away from the athlete, so it's travelling in its horizontal motion. It has more vertical magnitude than it has horizontal. Okay, and we keep going up, alright. Then when we get to the top, there's actually no vertical component at the highest point of the flight because it isn't actually going any higher. We then start to take an effect where actually there is now no more positive vertical component. Now it can only be affected by gravity, which is why the vertical component decreases during the flight. Air resistance is negligible, so both the horizontal and vertical components are unaffected by air resistance. Okay, they've stayed the same all the way through. So as we come all the way down, the vertical component becomes negative and actually gets bigger because that's what's bringing it down. Okay, this is due to gravity. So let's go back to the question then. We need to evaluate the flight path of a shot put, and it's worth 8 marks. So our command word then is evaluate. Now when we get evaluate as a command word, this means that we need to give lots of different options, ideas and arguments and come to conclusion at the end. The topic is projectile motion because we've got flight path, and our focus has to be on a shot put. Now initially we need to start with AO1, where we identify and describe and showcase our knowledge. Then we go to our application, where we look at examples, and here we need to relate everything back to a shot put, and that's AO2. And then we need to give our reasons saying why, AO3. So let's have a look then. So if we head over then to the blue box, and we'll have a look at the AO1, the identify and the describe section. Now it's 8 marks, so it's only worth 2 marks maximum. So what's the projectile motion? That's the movement of an object or body as it travels through the air. Horizontal displacement is the shortest distance from the start point to the finish point in a line that is parallel to the ground. There are 2 components to motion, that's vertical and horizontal. The vertical component is the upward motion of an object, which decreases during flight because it's affected by gravity. The horizontal component is horizontal motion of an object, and it reduces because of friction or air resistance, and a lot of the time it's very negligible. In AO2 then, so this is worth 3 marks of the 8. This is where we apply our knowledge to the shot put. So the shot putter is aiming for horizontal distance. The horizontal component remains unchanged because it's negligible friction, air resistance due to a large weight force. Vertical component, so it's large at the release, none at the highest part, and becomes negative before landing due to gravity. Results in a parabolic flight path, which is a uniform curve symmetric at the highest point. Distance achieved depends on angle of release. Angle of release needs to be less than 45 degrees for maximum distance. The height of release, so a high release height above landing height, which is best. Maximum distance depends on the speed or the velocity of release. So AO3, this is where we say why, it's worth 3 marks. So maximum distance depends on angle of release, height of release and speed of release. Angle of release should be smaller, so more speed needs to be generated as the shot's released. The optimum angle of release depends on the size, the strength and the technique of the person. The speed of release depends on the force exerted, so the greater the speed of release equals the greater distance or the greater horizontal displacement. The shuffle or the rotation in the circle, so this ensures that the shot put leaves the hand at maximum velocity to achieve maximum distance. A greater height of release equals a greater distance or horizontal displacement. Gravity is constantly acting on the mass of the shot put. Release at the highest point to maximise horizontal displacement. Wow, that's everything you should need to know on projectile motion. And make sure you remember how it links to the shot put and the shuttlecock. Bye for now.